Okay, so section 7.5, operations with matrices. This is pretty straightforward, just learning how to do addition, subtraction, and then multiplication with matrices. So properties, capital A and capital B stand for matrix A, matrix B. So commutative, you can add A plus B, or you could add B plus A, it doesn't make a difference. Associative, you could do B plus C first and then add A, or you could do A plus B first and then add C, it doesn't matter. Associative scalar, you could multiply the two scalar. A scalar is just a whole regular number, right? Not a matrix, but a regular number. You can multiply the scalars together first and then multiply it into the matrix, or you can multiply them one at a time into the matrix if you thought that was helpful. Scalar identity, 1 times A is still just A. Distributive property, you can still distribute a scalar into the two matrices and then add them together. And same idea with the scalars and distributing the matrix. So basically all the rules you think apply do apply. So it's pretty straightforward. I don't want to rush it, but I think you should be able to do these on your own. You find the term in the same location. So like row 1, column 1. Problem says plus row 1, column 1. And you add them together and your answer stays in row 1, column 1. So all the way through. If I was you, I would just pause the video, answer this, see if you get the same thing as me. So I just added all the numbers in the corresponding spots in each matrix. So doing something a little more difficult, I guess, technically. Number 2, 3 times A and B are given, matrix A and B are given. So maybe you want to do 3 times A first. Maybe you can do it all at once. That's your choice. But if I was doing 3 times A and then adding B, maybe I have to show this, maybe I don't have to show this. Either way, it's your final answer that we're grading. Do the math. A little wiggly there. And this is what you should get. Okay, next one. See if you can do B on your own. One thing I would personally recommend, because there's a negative sign in this one, be extra careful, right? I would distribute -2 into B and turn my equation into A plus whatever you get when you do -2B. But see if you can get the same answer as me. Pause your video. Okay, lots of places to make a tiny mistake, but hopefully you got the same thing as me, unless I made a tiny mistake. Adding and subtracting and multiplying by a scalar. Okay, next is multiplying two matrices together. One thing I want to write off to the side, A times B, again capital letters for matrices, is not the same thing as B times A for matrices. For matrices, the order matters. So make sure you keep an eye on that. Then, one thing we need to know about our dimensions, it's up at the top. If you have an m by n matrix, you're only allowed to multiply it by a n by something else, p matrix, and your results is m by p. So let's just say I have a matrix that's 3 by 4. I'm allowed to multiply that by another matrix that's 4 by really anything else, but I'll just say 5. The way you check it, those inside numbers need to match. That's how you know you can do the multiplication. The answer is going to be the outside numbers in dimensions. So let's look at their example in that little snip from the book that we gave you. This is part of why we need to learn dimensions of a matrix, right? 3 rows by 2 columns, 3 by 2. They want us to multiply it, A times B over here, multiply it by a 2 by 2 matrix. The inside numbers match, so it is possible, and my answer is going to end up being a 3 by 2 matrix. Notice that's not the answer. That's just the dimensions of my answer. Matrix multiplication, once you get the hang of it, it's pretty easy, but I am going to tell you it's quite hard to teach you not in person because I'd like you to be able to see like my fingers is I'm doing the problem. But in general, you're going to work to the right as you go through the first matrix, and then you're going to work down as you go through the second. So I would put my finger on the first number on my arrow and on the first number on my arrow here, and you multiply those together. That's where those came from. Then I move my finger to the right, and down. Both fingers get moved, right? And now I have two new numbers. It's always plus in the middle. All of these say plus in the middle. And it's those two new numbers multiplied together. That's where 3 and negative 4 come from. That's how I get the first spot in the first row, first column. If I'm doing first row, second column, I'm still going to go top row to the right, but now I'm going to do second column down. First number on that arrow times first number on that arrow, always plus. Then you move your finger to the right and move your other finger down. Those two numbers multiplied together. Notice now I've done every column, so I know it's time to move on. Second row, you go across, just like we've been doing. First finger, left finger, I guess, at 4, and then I'm going to do down on this one, right finger at negative 3, so 4 times negative 3. Then it's plus always. You move right 1 and down 1, and those get multiplied together. And then you do plus. I'm going to jump down because this is going to get messy. What if I want to do bottom row, last column? So this is my rows. That tells me what row I'm on, and this tells me what column my answer is going to be in. So bottom row, last column, first number times first number. That's where that comes from. Move to the right, move down, last number times last number, and then you add. Finally, over here, when they add them together, that's your solution matrix, and you'll notice it's a 3x2 matrix. Okay, ready to try it on our own? Again, I highly recommend using your fingers in that method that I'm drawing with the arrows. It's a lot less messy if you're just using fingers and not drawing the arrows every time. Let's first check and see if this is even possible. So, this matrix, write down the dimensions of each matrix. 2 rows, 3 columns. They want us to multiply it by a 3x3. Those inside numbers match, so it is possible, and the results are going to be a 2x3 matrix. I make my matrix extra big, and I just start it, and I don't close it because I need a lot of room to do work. I highly recommend showing all your work when you do these, otherwise it's really hard to keep track of what you're doing. So this spot is going to represent first row, first column. So first row, I'm going to go across the top row. First column, I'm going to go down the first column. It's a 1. Oh, it's a negative 1. Make sure you don't write over the problem. Okay, so first point on my arrow, 1, times first point on the other arrow, negative 2. Always plus. Now move to the right 1 and down 1. 0 times 1. Always plus. Now move to the right 1 and down 1. 3 times negative 1. Once I do all that math, I'll know that number. Let's write our answers here. So it's going to be a 2x3. So let's see. This is negative 2 plus 0 plus negative 3. So negative 5 is my first answer. Okay, I like to stay in the top row. So it's going to be 2x3. So let me just set it up for you. Depending on how much space you need, it's going to be 2 rows by 3 columns when we're done. Okay, I like to stay in the top row, so I'm going to do this arrow again, but I'm going to make it the same. And now I'm in the middle column, so now I'm going to do this one. So first point on each one, 1 times 4. always plus. Now move your finger right one and down one. That puts me at 0 times 0. Always plus. Now move right one and down one. That puts me at 3, 1. Do that math and you'll get that answer. 4 plus 3, it's going to be 7. Okay, one more in the top row. So again, across the first row of the first matrix, but down the last column. See if you can fill in the math there. Pause your video and see if you get what I do for that top row, last column. Okay, so 1 times 2, move right, move down. 0 times 0, move right, move down. 3 times -1, and always plus in the middle. When I do that math, I got an answer of -1 for that spot. Okay, now we're going to the next row. So now I'm going to erase this if I can. We checked, we know it is going to be possible, so now I don't need this down here anymore. It's in my way. Okay, so now we're going to be working on the bottom row. Everything we do is going to go across that bottom row. When I'm doing first column, it's going to go down the first column again. See if you can figure out what that spot in your matrix is going to be. Okay, so starting with the 2 and the -2, then it's right and down, plus in the middle, -1 times 1, plus in the middle, right and down, -2 times -1. When I do that math, I get -3. See if you can fill out the middle one. So, not the middle one, sorry. Bottom row, middle column. So still across the right, but now I'm going down the middle again. Okay, so 2 times 4, plus -1 times 0, plus -2 times 1. When I do that math, I get 6. Last one, still the bottom row. Now I'm going down the last column. See if you get what I get. Okay, 2 times 2, plus -1 times 0, plus -2 times -1. My final matrix, I put a box around it at the top. -5, 7, -1, -3, 6, 6. Okay, a couple things to notice when you're doing these. I might make some highlights, but I'm going to erase them after I talk. Notice my top row, every single one went 1, 0, 3, 1, 0, 3, 1, 0, 3, because that all came from the top row of my first matrix. Bottom row, they all go 2, -1, -2, 2, -1, -2, 2, -1, -2, because that all came from the bottom row of my first matrix. Same idea for the columns. I'm just going to look at the last one. 2 over 2, 0 over 0, -1 over -1. So you should see some patterns, especially when you're all done, to make sure you are using the right numbers at the right time. Okay, example 2. Check and see if it's even possible. So write your dimensions and figure out what the dimensions of the new one's going to be. So this is a 2 by 2 times this is a 2 by 2. The middle twos match. My answer is going to be a 2 by 2. Might as well make a spot for my answer right here. Okay, my work. 2 by 2. Places to do the math. And I'll write the answer up above. So why don't you try first row, first column. See if you get what I get for the math and for the answer if you'd like. Pause your video. 3 times -1 plus 4 times -3. I got -15 for that first spot. See if you can do the top row, second column. You can just do the whole thing if you'd like, but I'm going to do top row first and then I'll do second row. 3 times 2 plus 4 times 0 gives me an answer of 6. Second row, first column. -2 times -1 plus 5 times -3 give me -13 for that term. And then do the last one. -2 times 2 plus 5 times 0 gave me -4 for that term. Okay, see what you can do with the next problem, number 3. Okay, it's a 2 by 1 times a 3 by 2, which does not exist. The numbers in the middle don't match. Or, if you tried doing that row thing, you'd go across this and down that. Well, I would need to go all the way down. So I would need 3 numbers to match, and I only have 1 number over there. So moving your fingers and doing the arrows doesn't work. So the answer does not exist. See what you get on number 4. See how far you can get on problem 4. Okay, so just checking to see if it exists. 2 by 2 times a 2 by 1 will give me a 2 by 1. So I set them up with some space to do work. Here we go. Two times -3 plus, move to the right, move down, 5 times 2. -6 plus 10 gives me 4. One more. Cross the bottom and down still. -1 times -3, move to the right, move down, 4 times 2. 3 plus 8 gives me an answer of 11. There's my answer. You don't need the dimensions at the bottom, but there's the answer matrix. So hopefully that helps. There's practice online as well to help you practice your multiplying matrices.